Topic 8, Superposition. Part 5, Interference of Waves. Just refresh your memory on overlapping of two sets of diffracted waves. And the result of overlapping is interference. This is the interference pattern as a result of the overlapping of two sets of waves. If you like, you can print out this diagram and mark on it points C and D. To understand interference pattern, you need to know some basic stuff. First of all, look at this one here. This is what we call constructive interference. These two waves are in phase. A crest meets a crest and they build up each other. A trough meets a trough and they also build up each other. So the resultant wave is bigger. Here is what we call destructive interference. These two waves are out of phase with each other. A crest meets a trough and they destroy each other. A trough meets a crest and also destroy each other. So you get no wave. You can ignore this one here. The distance from the center of one slit to the center of the other slit is called D, and it is equal to 1 centimeter here. The wavelength is half a centimeter. From one crest to the next crest is half a centimeter. Look at this point A. This is where two crests meet. This crest here comes from this slit. This crest here comes from this slit. They meet here, so they build up each other, and that's what we call constructive interference. Look at this point here called N. This crest comes from this slit. This trough comes from this slit. So a crest meets a trough and it destroys each other, so there is destructive interference. This line here joins up all the black dots where there is constructive interference. This line here joins up all the yellow crosses where there is destructive interference. And this line is called antinodal line. This line is called nodal line. On the next 3 slides, we want to look at the effect on the number of nodal and antinodal lines of increasing the wavelength of these diffracted waves while keeping the distance D between the two slits the same. Here, D is 1 centimeter. From there to there, 1 centimeter. Wavelength is 1/4 of a centimeter from there to there. Here, the wavelength has increased from 1/4 to half a centimeter, so from there to there, half a centimeter. Here, the wavelength has increased further from half to 3/4 of a centimeter, so from there to there is 3/4 of a centimeter. You can draw your own conclusion from looking at the previous 3 slides and complete the following sentence here. Here we're looking at keeping the wavelength constant while increasing the distance D between the two slits. Wavelength from there to there, half a centimeter. D from there to there, 1 centimeter. D is now 1.5 centimeters from there to there. Now D is 2 centimeters. Once again, draw your own conclusion and complete the following sentence here. Now we look at path difference. Let's look at point A here. The waves from Y have a straight path from there to there. And the distance is 1 wavelength, 2 wavelengths, 3 wavelengths. So it's 3 lambdas. And the waves from X have a straight path from there to there. And the distance is 1, 2, 3, 4 wavelengths. So 4 minus 3 is 1 wavelength. So the path difference at point A is 1 wavelength, as it says here. Now look at B. The path from Y to B is 1, 2, 2.5. the path from X to B is 1, 2, 3, 4. 4 minus 2.5 is 1.5. The path difference at B is 1.5 wavelengths. See whether you can come up with a general formula in terms of path difference for the constructive interference and also for the destructive interference. All these are different pictures of double slit interference. In particular, let's look at this one here. All these red lines are antinodal lines. Look at this central one here. All the points along this line have a path difference of 0. That's why n is equal to 0. N stands for order number. All the points along this line have a path difference of 1, so n is 1. All the points along this one have a path difference of 2 lambdas, 2 wavelengths, so it's 2. These blue ones are nodal lines. Look at this one here. All the points along this line have a path difference of half a wavelength, so n is equal to half. All the points along this line have a path difference of 1.5 wavelengths, so the order number is 1.5. Here is 2.5. Likewise here and here.